Welcome to The Explainer. Today, we're diving into how one of the most basic things for life, oxygen, can be transformed into a high-tech medical treatment, one that can literally pull complex surgeries back from the brink of failure.
So let's set the scene. It's a high-stakes situation. A patient just got through a major reconstructive surgery. The surgeon has placed a new piece of tissue, a graft or a flap, perfectly. But then disaster starts to strike. The tissue isn't getting enough oxygen and it's starting to fail. The whole surgery, all that work is in jeopardy.
Now, to really get what's going on here, we need to talk about two incredible tools in a surgeon's toolkit: skin grafts and flaps. These are the cornerstones for fixing really complex wounds, but their survival is never, ever a sure thing. And here's the key difference between the two. A graft, well, think of it like laying down a new patch of sod on your lawn. It's totally cut off from its old life support. It has to grow brand new roots or it's just going to die. A flap, though, is more like moving a whole shrub with the root balls still attached. That built-in blood supply gives it a huge head start for survival. You see, the success of these things is pretty fragile. A lot can go wrong. Maybe there was some trauma, or the wound area was damaged by radiation therapy. But you know what? All of these different problems, they all lead to the same critical issue: hypoxia. A severe, desperate lack of oxygen that just starts killing off that brand new tissue. So that's the problem, right? Not enough oxygen. So what if? What if we could basically force-feed oxygen to that struggling tissue? Well, this is where things get really, really interesting. And that solution is called hyperbaric oxygen therapy, or HBO₂ for short. Now, this isn't just about putting an oxygen mask on a patient. No, we're talking about putting them inside a special pressurized chamber. That pressure does something amazing. It allows their blood plasma, the liquid part of their blood, to absorb and carry way, way more oxygen than it normally could. It basically supercharges the body's entire oxygen delivery system. And this super oxygenated plasma can push oxygen deep into those tissues that are starving for it. But it's more than just a temporary fix. It actually kicks the body's own healing powers into high gear. It tells the body, hey, grow new blood vessels right here. It helps build new connective tissue. It even protects the tissue from other kinds of damage. It's pretty incredible stuff. Okay, that all sounds fantastic in theory. But the big question is always, does it actually work? Well, to answer that, we have to follow the evidence, which builds its case from the lab all the way up to real-world patients. You know, in medicine, not all evidence is created equal. There's a hierarchy, this pyramid you see here, called the levels of evidence. Ideas start at the bottom with lab work and animal studies, and they have to prove themselves to climb all the way to the top, the gold standard of human clinical trials. And let me tell you, some of those early animal studies had truly jaw-dropping results. Just look at this. In one key study, the control group, the one with no special treatment, had a graft survival rate of about 26%. Not great. But the group that got HBO₂ therapy, their survival rate jumped to 82%. That's not just a small improvement, that is a massive difference. With results like that, you can bet researchers felt they had to see if this incredible effect could be replicated in people. It wasn't just a scientific question anymore, it was an ethical one. And when we look at the human data, we see a really solid case being built. Now, there's only one level 1 study, that's the top of the pyramid, a randomized controlled trial, but we also have level 2 evidence from studies with almost 2,000 patients combined. Plus, you've got lots of smaller case studies, all pointing in the same direction. This therapy seems to work. Okay, so the evidence is there. But how does this play out in a real hospital, in the middle of a crisis? How does a surgeon decide, okay, now's the time? Well, it's definitely not a guess. They follow a very clear, logical roadmap, kind of like the flowchart you see here. This helps guide the whole medical team through a step-by-step process to make the absolute best call for the patient. It's actually pretty straightforward. First, the surgeon sees the signs that the tissue is in trouble. Second, they double-check to make sure there isn't a simple mechanical fix, like a kink in a blood vessel they can just straighten out. If there's not, then comes the most important part. Step 3. Start HBO₂ therapy right away, as soon as possible. Because time is tissue. The faster you start, the better the chance of saving it. Then you just monitor and adjust as you go. So what's this actually like for the patient? Well, they'll spend about an hour and a half to 2 hours inside one of these special chambers.
They're breathing pure oxygen at more than double the normal pressure we feel every day. And they'll do these sessions daily to keep that healing process moving forward.
So let's cut through all the science and the process for a second. Let's bring it all home. What is the real-world impact for the person whose surgery, whose body is on the line?
This quote from that top-tier gold standard study really says it all. Complete survival, we're talking the entire graft made it, happened in almost 2/3 of the patients who got HBO₂. And in the group that didn't, it was less than 1 in 5. That's not just a difference, that's a total game changer.
To put another number on it, that same study found a 29% overall improvement in how much of the graft survived. So even if the whole thing isn't saved, you're still saving significantly more of it, which can make a huge difference in the final outcome.
And for flaps, the results are just as stunning. In a big study on severe war injuries, flap death was a tragic outcome for more than half of the patients in the control group. With HBO₂, that number was slashed all the way down to just 15%. Incredible. So what's the bottom line? It's simple. Saving that original graft or flap means the patient gets to avoid more surgeries. That means less pain, less time in the hospital, and less cost. It means they don't have to go through another procedure to take tissue from somewhere else on their body. It gives them the absolute best shot at a successful reconstruction the first time around.
So, by taking something as simple as oxygen and putting it under pressure, hyperbaric oxygen therapy offers a crucial lifeline in some of the most difficult situations in surgery, and it really makes you wonder, what other complex wounds could we heal if we just harness the power of this fundamental element of life?